Our final video on geometry will be on bearings. So any persons complain about difficulties with bearings, it's pretty simple, as you're going to see in this video. So what is bearings? Bearings is moving or traveling in a particular direction, right? So there is the cardinal direction there, the north, south, east, and west. Now every direction has a bearing. And there's two fundamental things that you need to know about bearings. Bearings is measured in a clockwise sense from north. So you start all of your measurement from north. And bearings is represented using 3 digits. So here is your 3 digits. North is 0, 0, 0 because you start counting from 0. You start measuring from north. And this is the clockwise sense. You're going in that direction all the time. Okay, so north east is 045, east is 090, 90 degrees, southeast is 135, south is 180, you can see that straight line, and so on and so on. You can see these numbers. There are a few properties of angles, we did this already, that are used in bearings. That will be the alternate angles, interior angles, and angle at a point. All right. So also angles on a straight line. So let's get started. These are some very, easy exercises we can use to better understand how to draw bearings. We said the bearing of A from B is 60 degrees. All right. We're starting from B. Whenever we're drawing a bearings, the first thing we put up is our north. So that's my north. What I also do is put a little cardinal direction thing there so I know what quadrant I have to draw my angle in. This is, as you can see over here, this is this first quadrant here, this 90 degree here, is in quadrant, is between north and east. So the angles that are between north and east are angles between 0 and 90. So this 60 has to be in the first quadrant here. It's more than 45. You don't have to draw it accurately. You just need a good sketch. It's more than 45, so it comes something like that. So we start from B, this is B. A from B, this is A. And this is the angle it created, 060. And this is how you draw bearings. The bearing of P from Q, which means we're starting from Q, is 140 degrees. So first thing we always do is to put up our north. And I normally put this. 140 is greater than this 90 here. It's less than 180. It's less than, so it's somewhere between here. Somewhere between southeast and south. So it has to come somewhere there. And this is a good sketch as well. This is P from Q. This part is Q, this part is P. This is my angle, 140 degrees. You can try these two, 233 and 320. Stop the video, try it. Okay, so now I'm going to do it. The bearing of L from K. So we started from K, and every time we draw a bearing, we have to put up a north. So that's my north. L from K is great. 233 is greater than 180. It's also greater than 225 on this side here. So it's there. So it will be very good if you remember this diagram here, that cardinal direction there. So it's greater than 225, so it comes there. And this is L from K. So this is L and that is K because we started from K. And this entire angle around here is a 233 degrees. That's how it goes. And the final one And then we'll have to do it all over again. All these things we have to do all over again. So you can get another idea about bearing. So the bearing of x from y. So we're starting from y. Put up our north first. Is 320. 320 is just more than 315 on this side here. So it goes that way. So the entire angle there is 320 degrees, and it's L from, no, it's X from Y. So this is Y, and up here is X. And that is our bearing. Let's go back from the top. Now the next question they can ask you, if the bearing of A from B is 0, 6, 0, what is the bearing of B from A? Where are we starting from? A. So we start our measurement from A, and every time you're going to measure a bearing, you have to put a north. Every single time you measure a bearing, you have to put a north. So that is my north. All right. And the bearing of B from A will be this entire angle here, this big angle around here, because it's measuring a clockwise sense. So you have to go around from this side, come around there, from north. How do we get that? There's two ways of doing it. I'm going to show you the first way. If you notice the arrows, this is interior angle. And we know that interior angles are supplementary. So if A is 60, over here, being supplementary means you add up to 180. Over here must be 120. This entire angle from there to there has to be 120. And all the angles at a point will add up to 360. So if we subtract the 120 from 360, we'll get the other side. And this will be 240 degrees. So the bearing of B from A is 240. Let me show you the other way in which you can get it, right? So I have to draw back my B. I also have to draw back my A, put my north. Good. This is A. This is 060 degrees. The bearings of A from B is 060, how do I get the bearings of B from A? I want to start my measurement from A. How do I do that? If I extend this line, well, first let me show you this. If you notice the arrows again, this is alternate angles. See? Z angles. So under here will be 060. There will be 60 degrees. And this entire side is 180. So if here is 60 and there is 180, 180 plus 60 is 240. That's one way, right? And there's another way by which they would normally extend this line here. When they extend this line, this will be corresponding angles. Over here will be 060. And if you notice this, the straight angle on there, this will be 180 as well. So there's three ways of doing it. So the bearing of B from A is 240. Okay, so you have the privilege of finding the bearings of Q from P. Put up your north, extend, you can do it like this, or you can do it with the alternate angles, or you can do it like that with the interior angles and you subtract from 360. Okay, you can find that. Find the bearings of L from K. Find the bearings of X from Y. All right, this one will be pretty simple because it will just be the angle in there. Find the angle in here, subtract from 180. Well, you know the properties of angles. Okay, so now we get into the calculation meat of bearings. And then this is one of the past papers. This was May 2008, question 12. Let's solve this question. But first, let's solve this question. A car traveled 40 kilometers on a bearing of 237. Calculate the north, the south and west distance. South and west distance. South and west distance. What is that? Well, let's first draw this. This car traveled 40 meters on a bearings of 237. So let's say we start here. And then we start right bearings. Start with our north. This is 180, so this is bigger than, this is less than the 230. It's less than 270 here, so it doesn't go past there. It doesn't go, it goes past 225, so it's somewhere here. So this is the 40 kilometers that the car traveled. What south and west distance is the question talking about? Well, the angle there is 237. This will be the west distance. That will be the west distance because this is west. Now, if I come down, this will be the south distance. But if I also come down here, it will also be the south distance, right? Because these distances will be the same. It will be like a square or a rectangle. Okay. So this is the south distance. This here. Let's call this S and let's call this the car. What is the angle in here? If up to here is 270, this is 90 there. Then to get the angle in there will be 270 minus that 30, that 237. And that will be 33 degrees. Alright, so we end up again with a right angle triangle. How do I know this is a right angle? Well, if this is a south distance, if I put the arrow there, you can see alternate angles. Z, bam. Also, with the cardinal directions, the south and the west and north and east, all those things form a 90-degree angle, as you see on the previous page. So how do I find the south distance? If I have, this is the hypotenuse, HYP, right? And this will be the opposite side. This will be the adjacent side. You can use either cos to find this angle first. This length first will be the south distance, the west distance. Or you can use sine to find this distance. Or you can find one of these distances and use Pythagoras theorem to find the third one. So you go right ahead and solve that. So this is a CXC question that we're going to solve. And I hope this helps you a lot. Let me read it quickly. A ship leaves port R and sails to port S and then to port T. The bearing of S from R is 112. The bearing of T from S is 033. The distance RT is 75 kilometers and the distance RS is 56 kilometers. Draw a diagram showing the journey of the ship from R to S to T. Show on your diagram the north distance, the bearings 112 and 033, the port R, S, and T, the distance is 75 and 56. And this on this side, it asks us to calculate the size of the angle RST, calculate the size of the RTS, the bearings of R from T. Okay? And the ship then leaves port T and sails to port X, and X is north of R. And let's work that out. So let's go. Ship leaves port R and sails to port. So it starts from R. I'm going to start from R. Anywhere I'm going to start from, I put my bearing. Probably should have come down a little. North. This is R. Sails to S. The bearings of S from R is 112. This is 90, so it's more than 90. And 22 plus the 90 will give you the 112. So it's less than 135. So it's somewhere here. Sails to S. This is S. Let's make this a bit longer. Again, this is an average. This is not the accurate thing. S. Good. And this bearing here is 112 degrees. It then says to T. T is the bearings of T from S is 033. 033. If I'm right there, if I'm drawing a bearings, I have to put my north. First thing I put is my north. And 033 is less than 45, which is in this first quadrant here, so it goes up like that. Good. 033 degrees. Good. The distance RT is 75 from R to T, so we have to connect R to T. This is T. R to T is 75. Just going to draw broken lines. You don't have to draw broken lines. This is 75 kilometers. The distance RS is 56. R to S is 56 kilometers. Okay, good. So we have to show our north. The question says show your north distance, the bearings, the points, and the good. So this is your diagram. Pretty simple. Pretty simple. Just follow. Every time you're going to draw a new bearing, you have to put up a north and you draw your distance. It's a good sketch. Okay, so now we have to calculate the size of the angle RST. So the angle in here, this entire angle in here. We already have 33 degrees of this angle. If we get this one, we can add these two and get what the entire angle is. This is 112. This, if you look at the arrow, these are interior angle. And I also said that the properties that are used in bearings are alternate angles, interior angles, angles at a point, and angles on a straight line. Okay? So, or if you'd like, you could have and yeah, this would be correct. If we bring this down, we can see the alternate angle. So we subtract 112 from 180 and we'll get 68. 68 will be here. That's the straight line, if you can see. So, and if this is a Z angle, alternate angle, then also here is 68. Also, if this is an interior angle, which is because of the arrows, interior angle are supplementary. So we subtract 112 from 180 and we'll get 68 degrees. 068 degrees. You cannot leave for, you have to use 3 digits. So this entire angle there, the angle RST is equal to 068 degrees plus 033 degrees, which will give you what? That is 101 degrees. So that was simple. Then they asked to calculate the angle RTS. RTS. That is the angle at T here. They want that angle there. So how do we get that angle there? We have the length of this side. We have this angle opposite here. We have this side and we want that one. So we have to use the sine rule, not the cosine rule. So cosine rule is used when given the length of two sides and the angle between. Or if you want to find an angle, they will give you all 3 sides and ask you to find one angle. So we have to use the sine rule. So this is T, this is R, this is S. The fractions that we need is T, because we need to find that angle T, and S, because we have these two. So this is question B1, this is B2. I'll have to go on the next page. I'll come back and do whatever other drawings and explanation I need to do. So we say T over sine T is equal to S over sine S. We don't know T is 56 km divided by sine t. We don't know what the angle is. And that is equal to S is 75 km divided by sine S. S is 101 degrees. This entire angle is 101 degrees. So let's find what sine 101 is. And we'll get 0. So let me write here, cramping it here, I hope you can see. 56 km divided by sine t is equal to, this is 75 kilometers divided by 0.982. Right, coming up here. So 56 km divided by sine t. When you divide that side, 75 kilometers divided by 0.982 will give you 76. This is equal to 76.375 km. Then you cross multiply. 56 km is equal to sine t times 76.375 km. Then you bring over that. 56 km divided by the 76.375 km is equal to sine t. When you divide this side, going on the next page. So sine t is equal to 56 divided by 76 point, what's that? 375 will give you 0.733. So t, the angle t is equal to sine inverse 0.733. The angle t is equal to 47.14 degrees. This is the angle. They did not say put it to 1 decimal point or anything of the sort. So I was going to, but I'm not going to because it didn't specify how to put your angle. So we leave it like that. So that's the angle here. That is the angle 47.14 degrees. That is the angle at T. The next question is the bearing of R from T. The bearing of R from T, which means we're starting from T. Alright? So this is, if you're going to start from T, we have to put a north. The bearings of R from T. So you have to put a north at T. So how do we get, okay, very good. We have to use the properties here. There's several ways in which we can get this here. I'm going to show you one, extend this here. We need this entire angle here, from here in a clockwise sense from north to there. We have this as 47.14. What is this angle in here? We know this is 180. That's a giveaway. That's a straight line. So you don't even need to calculate that. What is the angle in there? If you look carefully, you'll see alternate angles. So the angle in here is 0, 3, 3. So to get what the bearings of R from T is, it's 180 plus that 33 degrees plus that 47.14 degrees, which will give us 260. The bearings of this question here, the bearings of R from T will be 180 plus the 0.033 degrees plus the 0, sorry, if bearings is measured using three digits, then we can put this as 0.47 degrees and not put the decimal point. That makes more sense now. 0.47 degrees. So when you add all this, you get 260 degrees. The bearings of R from T is 260 degrees. Pretty good. Okay. So I hope this doesn't look messy. I hope you understand what's going on there. The final two questions. The ship sails from T to west of, sorry, let me read it again. The ship leaves port T and travels due west of a point to a point X, which is due north of R. So the ship leaves T and goes west. West is in this direction. And goes west this is going to west, and west is north of R, so west is up here. Let me bring this up, right up. So this is a right angle triangle, that little triangle up there, with the hypotenuse being the 75 kilometers. This little angle in here will be very helpful. If this entire thing is 260, as we said, and up to here is 270, then this would be 010. This would be 10 degrees. So we have a right angle triangle with one angle being 10 degrees. Okay, so show on your diagram the journey from T to, okay, that's our journey there, from T to X. This point is X, not W. W is the cardinal direction. Point is X. And calculate the distance TX. So that's this distance here. This is going to be the adjacent side. Let me abstract that triangle from all that confusion. So we have we have T here, we have X here, we have R there. This angle is 10 degrees, right? This distance, that's a right angle. This is 75 kilometers. They want this distance. This is the opposite side. This is the hypotenuse. This is the adjacent. So I'm absolutely sure you can calculate that. What ratio should you use? We're not asked to find the opposite, and we're given the hypotenuse, so we can't use sine. We're asked to find the adjacent, this small r, and this is the x, so we have to use cos. Adjacent and hypotenuse is cos. Cos theta is equal to adjacent over hypotenuse. Cos 010 degrees or 10 degrees is equal to, this is what? R over x. So cos 10 is 0.985, and that is equal to r. We don't know what r is. X is 75 kilometers. So we cross multiply 75 kilometers times 0.985 is equal to r. So 0.985 times that 75 kilometers will give you 73.88 kilometers. R is 73.88 kilometers. I hope this helps you with bearings. There you go. That's your business and video on bearings. We have covered everything on the geometry and trigonometry.